All right, so this is about solving equations, quadratic equations, where you don't have a trinomial, you have a different situation. Okay. You're getting to the point where you're a little more mature, so you have to kind of look at the equation and try to figure out what they've given you. So, for example, you've been given stuff like this before now. Okay, you've been given stuff like x minus 3x minus 4 equals 0, for example, and it was set to 0 and you used the zero product rule. Okay, and you factored this. Okay, and however you guys factor this is the factorization of it. And then you set each one of these equal to 0. This is just reminding you where you were. Okay, x plus 3 equals 0, x is equal to -3. Well, these are your two answers, okay, for this. What does that mean? It means that if you plugged in this into this equation, you're going to get 0, okay? It's going to have bigger implications later, but for right now, these are called the solutions, okay? Again, you plug that one in, you would get 0, okay? That's where we have been, okay? You've also been given this x squared plus, let's say, plus 2x plus 1. And when you factor this, you get x plus 1 times x plus 1. This is a perfect square trinomial. And the whole point of doing this in completing the square was to get to this point. Okay. Now, at this point, I don't think you guys have done completing the square to solve equations. That's what this is. That's what's in this video. Okay, but this is where we are going. Okay, this is the factorization that you're kind of expected to know at this point, being able to factor these quadratics. Well, this is where you've been. Okay, but take a look at what they've done with this one, or what is existing here, so that you can take a look at it and then ask yourself, what do I have? So you have a u squared equals 81. Now, I know this is a simple problem, but the reason why I want you guys to take a look at it is notice that it's missing the b term. In other words, if you have x squared, ax squared plus bx plus c equals 0, for example, the a, b, c, right, are the coefficients, right? Well, we have a is 1, we have c is 81 or -81 once we move it over, but it doesn't matter. The point is that the bx is gone. Okay, when the b is gone, you can solve it in a more simple way. You don't have to factor it like this. You can simply notice that this is a quadratic and you could take the square root of both sides. And I'm going to do that in a different color just to get you to see that what we're doing is we are doing this. We are going to take the square root of both sides. Why can we do that? Because we have u squared on one side and a number on the other side. Okay, so if you can get it to this point, right, you can take the square root. So I would get u is equal to plus or minus 9. Now remember, it could be either one, and you have to list both of them, okay? Because -9 squared equals 81. -9 times -9. And 9 squared, of course, equals 81. So you got to be careful with this. By the way, -9 squared does not equal 81. That equals -81. That is the negative of 9 times 9. That's what this means. Unless the negative is in the parentheses, it's not part of the base of the exponent. All right, so simply enough, if you have something like this, x squared equals 49. You take the square root of both sides, and x is equal to plus or minus 7. Now, this is a pretty easy one, okay? But we're going to be using this quality right here, that x squared equals, to solve these eventually and use it for a very sophisticated way to move from standard formula to vertex formula in a second, okay? Take a look at the next problem. So here you're given something like x squared equals 19. Well, the issue here is that you're not given a perfect square. It's really nice when you're given something like x squared equals 16. You're like, ooh, okay, I'll take the square root of both sides and I get x is equal to plus or minus 4. Okay, well, that's nice, right? You took the square root of both sides. Well, that's all fine and dandy, but what do you do when you don't have a perfect square? So in this case, you have x squared equals 19. It says simplify your answer as much as possible. Okay, you are not allowed to use a calculator here. You are simply supposed to leave it in exact notation. So let me write this down because this is really important. Okay, when they use the word exact, it means leave the leave the square roots in there. Okay. When they say approximate, that means, let me do this. That means use decimals. You can use your calculator and get decimals. Okay. So it says simplify as much as possible. So you're given x squared equals 19. Well, you take the square root of both sides. Okay. Guys, understand these undo each other. Okay. Much like we were, when to undo subtraction or addition, like we did before. Like say, like if you have this, x plus 3 equals 8. This is just reminding you. You're like, what do I want to get rid of? The plus 3. What is it doing? Adding. What do we do? Subtract. Okay. Okay. In the same way that you kind of ask yourself, I'm going to erase that because I don't want it to be confusing. Okay. In the same way that you ask yourself those questions, you ask yourself here, okay, what do we need? We need x by itself. Well, it has a square. How do I undo that? You take the square root. That's how you talk yourself through this. Now, there isn't a square root of 19. 19 is prime. So guess what? You just leave it. That's it. Okay. Now, you might not be getting a prime number. You might be getting a composite number, but it has a prime in it. So let me go back real quick. What if you were given something like x squared? I'm going to change color so you know I'm starting a new problem. Okay. What if you were given something like x squared equals, let's say, 24. Okay, you can take the square root of both sides, but you have to simplify it. So it's going to be x is equal to, because these two cancel each other out, right? Okay. You break 24 like we've learned before. You break it into its pieces. So the idea is that you are breaking 24 into the pieces that make it up. Okay, so you're looking for perfect squares. So if you remember perfect squares, they're 1, 4, 1 squared, 2 times 2, 3 times 3 is 9, 4 times 4 is 16. Stop that, please. Let's see, 16, 25, 5 times 6 times 6, 36, 7 times 7, 49, 8 times 8, wait, 7 times 7, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100. Basically, we're looking for breaking up numbers into their pieces and looking for perfect squares that go into them so we can simplify. I'll tell you right now, the majority of them are going to have 4 or 9. Like they keep you in low numbers, but sometimes they'll do 25. These are the most popular. These first, obviously 1 isn't helpful, but 4, 9, 16, 25 are really actually the most popular. 36 is sometimes happening. I mean, they all happen sometimes, but I'm just saying the most popular. So we're going to break up. 24 is divisible by 4 and 6. The square root of 4 is 2. So x is equal to plus or minus 2 root 6. Okay, let's try another one. Let's say you have something like y squared equals, y squared equals, let's go with 30, not 36, let's go with 32. Okay, 4 goes into 32, but so does 16. So you want to usually typically pick, let's take the square root of both sides, the biggest number. So if you jump to 16, you'd get to the answer right away. Like if you knew that 16 went into 32 twice, you'd be at the answer, which is plus or minus 4 root 2. Okay, but if you didn't, let's say you only remembered 4 went into 32. You did this. That's fine. That's 2. The square root of 4 is 2. But 8 can still be broken up. So you get 2 times the square root of 4 times the square root of 2. See? 8 is actually 4 times 2. So this is 2. And then 2 times 2 is 4. You get y is equal to plus or minus. Always bring in that plus or minus 2. All right, let's go to the next one. Okay. All right, so take a look at what we got here. Okay, we have a quantity squared, and you might be tempted to multiply that out, but don't. Okay, this here we're gonna use that to our advantage in solving this. And we have a number. Okay, we have a number and we have a quantity squared. Think of this more as if it were a squared minus 64. That's really kind of what you have, where a is equal to y minus 8. I hope you can see that. Okay, I could have put anything. I could have put star squared. The point is that this quantity, we're trying to see this y minus 8 as a quantity. So what we do here is you have y minus 8 quantity squared minus 64 equals 0. So the strategy here is move the 64 to the other side. And then you would get y minus 8 quantity squared equals 64 because you add it to both sides, right? Now, notice 64 is a perfect square. 8 times 8 is 64, right? Okay, this is a square. So what's really cool is we can take the square root of this binomial. Okay, this is a nice little place to be. In fact, this is where we're heading with completing the square, by the way. Okay, so you take the square root of both sides. Oops, that's not a very good square root, Ms. Baca. Let's try that again. Okay, let's try this. Okay, we're going to take the square root of both sides. Then you get y minus 8 quantity squared. Not quantity squared. I'm going to take it out of parentheses now because I took the square root and I don't need the parentheses anymore because I'm not squaring it. You see what I just did? I canceled that square and I got y minus 8. And look, what we've done, this is amazing. We have taken the quadratic to a linear. Look, it's y to the first. We've gotten rid of the 2, and that was the whole point. We don't want y squared. We want y to the first power. We want to know what y is, not y squared. So this is plus or minus 8. When you take the square root of 64, you must leave the plus or minus in there. What that plus or minus means is that there's 2 answers that could be true. 8 times 8 is 64. Negative 8 times negative 8 is also 64. Okay, then we add 8 to both sides, and you're going to get y is equal to, move the 8 over, 8 plus or minus 8. Okay, I'm actually going to ask you to write the 2 answers. There are 2 answers for a quadratic, you guys, always. This means quadratic, possible 2 answers, okay? So when we do this, I'm going to have you write 8 plus 8 or y equals 8 minus 8. In other words, I just took this plus that and this minus that. And you get y equals 0 or y equals 16. And those are your 2 answers. Okay, I want to just touch on something really quick. You guys, remember I had you guys do this like quadratic and how many times it touches the x-axis? Okay, it's possible too, right? So it could also be none, correct? But a quadratic always is made up of 2 things that multiply together. Like x times x is x squared. So no matter what, there's 2 things. In this case, it's 2 real numbers. Okay. In the case of where it just touches the x-axis, sorry that this is crooked. I need to change my board shape. Here, we're doing like a skewed version of reality. Okay, in the case where it just touches at one point, that is 1 real. But it repeats itself twice. This is the case where you have like x plus 1 times x plus 1 equals 0. In other words, look, actually it's x minus 1 because I'm on the right-hand side. Let me try that again. It doesn't matter for you guys. I'm sure you won't notice it, but for me, it's going to bug. So here we go. X minus 1, x minus 1. In other words, the root is only 1. But notice, there are 2 factors. Okay, you still have to have x times x to get x squared, okay, for this quadratic. Now, when it floats, we have 2 imaginary, and you just learned about imaginary numbers. So when it floats, it's 2 imaginary roots. two imaginary roots. Okay, moving on to the next one. Okay, let's take a look. It's another example like this. Okay, I'll get green. I feel like we're going with green for some reason. All right, so here we go. You get x minus 8 squared minus 72 equals 0. You want to isolate the quadratic, okay? Okay, so we're going to add 72 to both sides. Okay, now, why did I do that? Let's try that again. I added 72. Okay, good. So I got, oh my gosh, guys, hang on, give me a second. Here we go. I can write 72, I promise. Okay, then you go, okay, I have a square. Ooh, I could take the square root. So I get x minus 8, take the square root of both sides, is plus or minus the square root of 72. Well, you're not done, okay? Because we need to move the 8 over to solve for x, but you're still not done, you guys. Plus or minus the square root of 72. Well, 72 can be simplified. There's something that goes into 72. Okay, 4 goes into 72, 6 goes into 72. Let's see what else divides into 72. If you keep going up, guess what? 36 times 2 is 72. So if you know your perfect squares, okay, you would be able to just divide that 36 times 2. And then this becomes 6. Okay. Cross out your square roots when you solve for them, because that way you don't leave them accidentally in the problem. So then this becomes 8 plus 6 root 2 or 8 minus 6 root 2. Okay, so you have 8 plus 6 root 2 or 8 minus 6 root 2. And those are your answers. You have to leave them like that. Okay, it doesn't say approximate. If it were approximate, you'd plug this into a calculator. Okay, but it's not. So you leave this. These are the answers, and this is the way they come. You typically put the rational in front of the irrational. Okay, next one. That it? Okay, that's it.